So last week there was a call out from a couple of you asking for a little more help on increase, decrease, positive versus negative, and domain and range. There was a few in behavior statements, and yes, you're right, it's not something you're going to use later in life, but what I will tell you is if we were in a classroom, and I tell every student every year, what you are learning is that you have to get through something you don't want to, nor do you think it's fun. That is a life skill. And then just following instructions is another thing that we have to figure out to learn to make this, I guess, relatively applicable to the real world. And reality is someone told us we had to, so we're going to, and we're not going to be bad at it if we can help it. So positive. So if we're looking at positive, this green section up here is everything that's positive because all of the Y values are positive. So if we're looking for intervals of positive, then it's going to be above 0. If we're looking for intervals that are negative, that's going to be below 0. So positive and negative. So positive versus negative, we're looking above and below the y-axis. So that's what positive versus negative is. So up here's our positive and down here's our negative. Now, your intervals, especially if you're not strong with domain and range. So domain is your x values, so that's left and right. And then your range is up and down, so that's your y value. In this case, this graph works its way all the way up to a positive 4, like right there. And then it goes down forever. So our range would be a positive 4 to negative infinity, because down is all our negative numbers. But back to our domain. Domain's what's really going to matter as far as your positive, negatives, increasings, and decreasing, because we're talking about the sections from left to right that those things are happening. So for positive, quote unquote, domain, that's going to be up here. Let's see if I can move our green out of the way and we'll see it better. Yep. So positive. So this graph, this polynomial graph, is positive from what looks like -2 here to +4. So our positive interval would be from -2 to +4. So all the way from -2 to +4. And you're going to use parentheses, because standing on 4, it's not positive or negative. You're on the 0. So you're right there in that weird gray area. So as far as brackets versus parentheses, I always like to think about if I can stand on it, it's a number and it's happening there, then it's a bracket. If it's just sort of like all the way up to there, but not quite like standing there, it's your parentheses. So our positive would be from -2 to 4. Now, we're looking at our intervals of negative. That's everything in the bottom before it crosses the x-axis. So this is our negative infinity over here. We're looking at our x values again. So we're going to the left negative. And then, so it's going to be from negative infinity. And then it becomes positive at 2, at -2. Then it becomes positive, and then we become negative again here at 4. So negative would also start from 4 to positive infinity, because we're going to go to the right forever in the lower portion of our graph. So that's your positive, negative. Now, increasing versus decreasing is a different conversation. That just means if you think back to linear, you were really good at it. A positive line is increasing, a negative line is decreasing. So if we look at each section of this polynomial as a bunch of different lines, then we'll see increasing versus decreasing. And remember, increasing means it's going up as we read from left to right. So for increasing, again, we're thinking about domains. A lot of us want to think the y values because you're looking at how high, like where it turns. But domain, again, is where we're focused. Positive, negative, and then increase and decrease is always x, so domain range. So from how far left to how far right do each of those things happen. So this is increasing from negative infinity all the way to a -1, because that's where it turns right here. So if you can find your extrema, your max and your mins, then you'll know your turn points. And again, we're using x values. So from negative infinity, so increasing from negative infinity, because we're looking at the left, from negative infinity all the way up until a -1. Sorry, not 2. Definitely -1 to -1. Then it goes down, so that's not increasing. And then we're going to increase again when it turns at our minimum point here, our relative min. and it starts to go up at +1. And it goes up until its next turn point, which is at 3. So 1 to 3 is increasing. Then our decreasing is just those spaces in between. So when it's going down, or a negative line in this case, maybe if you're referring back to our linear, like Math 1 and 8th grade math. So it's going down here, and it's going down here. So again, you're using your extrema, your max and min turn. So like this was my max, and it was at a -1,4. And this one was at 2,4. And this min, oh, I'm sorry, it's actually 3,4. 3,4. And then their min is at 1,1. But our y values don't matter because we're just setting up lots of mini domains. So it's decreasing here from -1 to +1. And again, you're using parentheses because standing right there at that -1,4, it's not going up or down. It's stopped. That's where it turned. So you're not going forward or backwards, or in this case, up and down. You're just standing still. So decreasing from -1 to +1, you're making that turn. Then you're coming up as an increase, and then we start to decrease again here at that 3 down to +infinity. So from 3 to +infinity. And again, parentheses, because at that 3 is a turn point. So it's not going up, it's not going down. It literally stopped to turn. Hopefully that helps you guys.